We have a length of day function, y equals 12 plus 2.4 times the sine of 2 pi over 365 times t minus 80. Remember, the 2 pi over 365 corresponds to the fact that we go through a complete cycle of 2 pi radians in 365 days. The t minus 80 shifts the starting point of the graph to the 80th day of the year, which is our March solstice, our spring solstice. The 2.4 represents the fluctuation above or below the 12-hour average day length. And if you do the circular model of this graph, you see all that. Now the question here is, when is a day length equal to 10 hours? Okay, so we solve for when y equals 10. To do that, of course, we set y equal to 10, and this expression here will then equal 10. So we write that equation like this. Just this whole side is the same. We've just set it equal to 10. We add negative 12 to both sides, and we get negative 2 on this side. So we got 2.4 times the sine of all this stuff, which I didn't bother to write here, equals negative 2. Dividing 2.4 into negative 2, we get negative 0.83 bar, 83 repeating. And now again I write all the stuff inside the sign here, because in the next step we're going to say that since the sine of all this stuff equals negative 0.83, then all this stuff is going to be the inverse sine of negative 0.83. Or possibly pi minus the inverse sine of negative 0.83, 2 pi plus the inverse sine of negative 0.83, and so forth, corresponding to the inverse sine, then around to 180 and backtracking the inverse sine, then 2 pi and doing the inverse sine, and so forth. Now we don't know which of these solutions will come out between 0 and 365 days. Actually, if we draw a careful graph, we can tell pretty well where that's going to occur. But let's pretend we don't have a clue, which is probably the case. Matter of fact, I guessed wrong on this one because I wasn't thinking very clearly. Looking at the wrong part of the picture here. Okay. To say that the inverse sine of negative 0.83 equals negative 0.898 is to say that, well, since the inverse sine of negative 0.83 is negative 0.98, then from the equation we see that pi, no, take that back. We're just noting here, the inverse sine of negative 0.83 is 0.98, pi minus the inverse sine of negative 0.83 is 4.12, 2 pi plus the inverse sine is 5.30. Again, corresponding to the quantities that we get here. We're just putting numbers on these three quantities. Then we set 2 pi over 365 times t minus 80 equal to each of these quantities in turn, and see which ones turn out with solutions for t that lie between 0 and 365. And we see that the first one certainly solves to get t equals approximately 23. So on approximately the 23rd day of the year, which would be January 23rd, the day length at this location would be 10 hours. Then again, later in the season, as the days get shorter, it's going to happen again. And that corresponds to setting the 2 pi over 365 times t minus 80 equal to the 4.12. 4.12 being the solution that we got for pi minus the inverse sine of negative 0.83. Okay, setting this equal to 4.12, we easily solve to find t is about 320. So at approximately the 320th day of the year, in late November, we're going to have a 10-hour day again. A graphical depiction of the situation. We first graph the function on a circle of radius 2.4. The inverse sine of negative 0.83 will occur here, and another point that has the same y-coordinate will occur here. On the graph, we project these points over, and we see that if the graph has been shifted to the right 80 units, so that instead of starting the sine function here, we started here, then certainly this intersection of the negative 0.83 value corresponds to day 23, and this one to day 319, where the complete cycle ends here. Okay, this is our 365-day year. This is our 365-day day length cycle. And we've got the parameters of the graph. If the circular model, just to review that a little bit, we have a circle of radius 2.4, centered at y equals 12, so that the low point is 12 minus 2.4, 9.6, corresponding to 9.6 hour day. The high point is at 12 plus 2.4, 14.4 hours, corresponding to a 14.4 hour day.